What happens when you have two of these rays crossing over each other is something like this. Here's a representation of one wavefront. Just going the other way. The red line here represents the ray of light, and it's going in that direction. But the ray actually consists of a lot of little waves, which are these vertical lines, which you can only just see. I'll zoom in a bit so that it's not aliasing so much. And focus. There we go. The red line represents the direction of the ray. The black lines are the wavefronts. If you have another set of lines laid on top of that, you then get a composite sort of a pattern when you alter the angle between the two of them. Now, what you're seeing here is usually called a Moire fringe pattern. I'll zoom out again to give you a bigger picture of that. And as you alter the angle between those two ray directions, that fringe pattern changes its spacing. Now, what you're seeing here is not interference. This is just two sets of lines overlapping each other, and the dark bits are where you have the line from one overlapping the gap from the other, so you don't see anything through it. The bright bits are where the lines are on top of each other, so you can see the gaps in between. But the pattern and the method, the geometry is the same as in true interference. So the point here is that as you alter the angle between these two lines, that fringe pattern changes. And you notice it's not very straight here, it's rather wobbly, and that's because the line pattern itself is not entirely uniform. There's tiny variations in its separation. But when you apply this to a light beam, you've got to think of this as travelling in this direction, along the direction of the ray of light, and you pick it up on a screen. So what happens is that if you have a pattern like that, on a screen over here, you would see light, dark, light, dark, light, dark, light, dark fringes. Points where the light is reinforcing itself and points where it is cancelling itself. Now, if we can use the video camera, we'll try and show that with real light, real interference. Here we have a laser set up with some mirrors so that we split the laser beam into two beams and then we overlap them again. We've got two spots of light, and they're from the same laser beam, but redirected via mirrors into different directions. But as we overlap those two spots of light, it's hard to see what's going on here, but now you can see things are twinkling a bit there. So if we expand that picture up by putting a lens in it to broaden it out, separate the two beams, ignore those ones off to the side. There's some stray reflections. The main two ones are the ones in the centre there. There are the two beams of light, which are the two laser beams directed into two different paths. As we overlap them, they'll be travelling in the same direction, and when that happens, we get these light and dark fringes overlapping where they intersect. Just have to turn down the exposure a bit to get there are the fringes that we're talking about. As the angle between them increases, the fringe separation decreases. There the fringes are fairly close together. As I'm bringing them closer to overlap, exactly the same direction, the fringe separation increases until, if we get it just right, they're going in exactly the same direction, and then the two beams of light can actually cancel each other or reinforce each other. So if I get the things adjusted exactly right, which is a bit difficult to do without taking a lot of time over it, we can get a dark fringe covering the whole lot. So that means that one of the beams of light is cancelling out the other one. If I block off one of the beams, we get light through it. If I block off the other beam, I get light through. But two beams together, they annul each other. What's happened to the energy? That's a good question. Think about that. It's still there, but it's not in this position. So that's the principle of interference. When the crests of the waves overlap the troughs, you get cancellation, no light. When the crests overlap the crests, then you get reinforcement, the light is 4 times as bright as it would be otherwise. If you had 2 lights together, you normally get twice the light, but if you've got interference, you get 4 times the light. You can see those fringes a bit better if I just shift this lens over here, and you can see a few more fringes as I increase the spacing there. You can see the bright and dark fringes. And as the direction becomes larger, the fringes get closer together, and vice versa.